It seems that learning Rust has put me into different situations where I had to face my unknowns with regards to computer science, and this video is one of them. Although I would say the topic that it exposes me to is very clearly defined, but at the same time very complex when it comes to its implementation. And the main topic is around bytes, characters, encoding schemes, and so on. And I came to this discovery by trying to compare the chars and bytes methods that are present on the string object in Rust. And before I start, I would like to give you a small challenge to try to predict what the results of running this small program will be. Of course, since I've put them side by side, there is very likely that the output will be different. And going beyond this, my question is, do you know why the results are different? Do you know the difference between bytes and chars? I put such questions to myself very often when it comes to learning, because I feel like whenever I try to let's say spark my curiosity, to give myself a challenge, I feel like learning is much more efficient that way. And so I try to apply this approach here as well. Of course, the results will be different, and now I'm going to run the program, and then I will try to understand or to explain, because I already did some research, and I'll try to explain why the difference occurs. I'm going to run this command because I want to suppress the errors. And as probably expected, there is one char, but there are 2 bytes. And the reason for that is that Rust uses UTF-8 for its encoding scheme. And what an encoding scheme is, before we start explaining that, it's important to have in mind the Unicode table, which is a huge table that contains mappings between let's say characters and their numeric representation. For instance, this character is part of the Unicode table. Okay, and now based on that Unicode table, there are different encoding schemes that determine how to represent those numbers, which essentially are characters, in bytes. There is UTF-8, which is what Rust uses. There is also UTF-16, which is what JavaScript uses, and those numbers 8 and 16, there are the number of bytes that, or to be more precise, they are the number of minimum bytes required for a single character to be encoded. This means that, and there is a very nice correlation between UTF-8 and the ASCII table, because in the ASCII table, the range in which a character can fit is between 0 and 255, because 255 is 2 to the power of 8 minus 1. Why 8? Because 8 is the number of bits. 8 bits means 1 byte, and basically this number here is in binary. I think it's basically in binary it is 8 of ones, or 8 ones, and this is the ASCII table, or let's say ASCII maximum range. And the correlation that I want to highlight very quickly is that basically with UTF-8 you can represent each character from the ASCII table using one single byte. What happens if a character extends or goes beyond the ASCII table and still using UTF-8, well, what UTF-8 ensures is that if a character is not in the ASCII table, meaning that it requires more than 1 byte, well, its representation will consist of at least 1 byte. And in the situation for this character, which will be a bit weird to pronounce, it's a Romanian letter, but just so you know that this character, as it seems, it requires 2 bytes because its code point is something like 259, which it's bigger than 255, meaning that its representation will require 2 bytes. And this is the reason that we are seeing 2 bytes here. And at the same time, 1 single character. And this can apply to other characters. If we were to pick, let's say, I don't want to spend time with an example right now because I might mess things up and I will ruin the entire video. But the idea is that if we pick another character from the Unicode table, which let's say that it would require at least 3 bytes. Let's say that it's some random Greek letter or something like that, then we would still have 1 character, but we would have, let's say, multiple bytes, because that's the starting point when it comes to, because as I said, using UTF-8, it ensures that the character will have at least 1 byte. And so by using a certain character from the Unicode table, we might end up with 3 bytes in total, or with 4 bytes, but still maintaining 1 single character. I'll make another video where I compare this with JavaScript, which uses UTF-8. And one last thing that I want to mention is that okay, so we have clarified that this requires 2 bytes, but if we were to have something like this, if you were to have a character that is within the ASCII range, then this will yield 1 single character as per UTF-8. My assumption, although I haven't verified this yet, is that this in JavaScript, I think this will have 2 bytes because the encoding system in JavaScript is UTF-16, which means at least 2 bytes for its representation, for a character way to represent. Yeah, so I think this will be it for this video. Basically, this wasn't more of a Rust video, but it was more of a general comparison between languages. And the beauty of that is that it has exposed me to fundamental concepts about how characters are displayed on the internet. I think there are at least 2 follow-ups video for this, and yeah, I'll see you in the next ones. Thank you.